Hello, and thank you for tuning in to the Flatirons Syndicate Motorsports Podcast. This show is brought to you by Flatirons Tuning, your source for any aftermarket or OEM Subaru parts. Be sure to check out our store at flatironstuning.com and stay tuned with Flatirons Tuning. Welcome back, everybody. Thanks for tuning in. This is episode number 55 of the Flatirons Syndicate Motorsports Podcast. We've got Dusix joining us, Scotty's in the shop, and we have a special guest with us today. We have got Paul Lucas from Verus Engineering sitting in with us today. So that we can talk about all sorts of stuff aero. Now, so Paul, we actually kind of found Verus Engineering through some other hard parts that you guys make. Like that's kind of what initially, brought us to your attention. I don't know how many years ago at this point, but I mean, would you say that it's fair to say that you guys have like aerodynamic parts you guys are developing has become a large part of what you guys do now?
Yeah, I would say aero parts are still our majority of our product. It's what we started with, because that's kind of been my focus. But we've since then, like when we got into the FRS BRZ, we benched out. We did some like clutch fork things. We ended up running into people would tell us that they have a certain problem with the car, and we'd come up with a solution for it. And then once we brought machining in house, we started to make other types of hard parts that weren't necessarily a problem, but we thought would be a good solution to make things a little bit better. Or some of the stuff we make are like engine dress up stuff also.
Sure.
We have machines, so. Sure.
Solving problems that are just known for the platforms that you support. But so Aerodynamics has been kind of that was actually the start, or where you guys got your foundation.
Yeah, our first part we ever made was the splitter. So our FRS BRZ splitter is, for our part numbering system, it's number one.
Number one. And it is number one, so that fits.
Yeah.
So now, when I was asking who I should talk to, and they all pointed me to you. So I want to kind of pick your brain about, like, when you look at a platform and we look at a car, like let's say the BRZ, and you want to try and improve the aerodynamics of the car. How much low-hanging, like, easy things are there to make, or like is it pretty involved, like what you would have to make to make a big difference?
I guess part of it would be like the definition of what like big changes would be. So like what I might view as like big changes might be massive changes to somebody else, and what I view as small could be big to somebody else. So like a lot of what we go into in like low hanging fruit, a lot of times depends on the car too. Like the FRS BRZ is actually a pretty solid car to start from. Like one of the cars that I just got done doing not too long ago is the GT350R, like from Ford. Surprisingly, like a lot of the aero side, besides like the 350R has like a factory diffuser and a factory splitter, but a lot of the other parts of the car, like there wasn't as much attention to detail as you have for like an FRS BRZ. So I would say like depending, like that car, so I think it had more low hanging fruit than say the FRS BRZ. Like there's not a whole lot of parts you would put on FRS BRZ that would say like decrease drag or massively change improvement without going with actual big hard parts like a splitter, a wing, a diffuser, or something along those lines.
Okay.
So a lot of it's platform specific. And honestly, a lot of new cars today they're so good. They're like so clean from the factory on overall until you start making more of a race car. When you start making a race car, then when people are willing to cut some things and drill some things and do things like that, it changes. So kind of how we go about like a platform is we judge, like first we kind of dip our toe in and see, like we make I would say parts for a street car that would also work well on a track. But I wouldn't say it's a track part. It's kind of a mix. And then if we see that the platform's doing well, like the FRS BRZ is primary example. It's a brand new car. No one knew how that was going to do when that came out. So when we were doing that, like no one knew it was going to turn into such a track car it is today. So we ventured into, like, obviously everybody drives a car on the street. So that's what we catered to, but we still wanted to make functional parts because both Eric and I are engineers. And that's kind of really what we like to do. We like to make it functional and good looking. And then it's not a race car. We do make race car parts now, but like early on, it was more of like streetcar parts that would work on the track.
Gotcha.
And
Go ahead, Scotty.
Do you, when you're starting with a new platform, are you going straight to CFD to test some of these parts for basically street, somewhat track?
Yeah, so like definitely like the process has kind of evolved as we grew and we have more abilities. Like as it works today, like when we get the new BRZ, we're gonna bring it into the shop, we're gonna put it on the lift, we're gonna look at it first. We like to visually look at it, see what's going on with the car, see what unique things they're doing, get some ideas, and then we'll fully scan the car, we'll solidify, and then we'll run CFD and we'll see kind of what the baseline of what the car is doing. And from there, we have ideas of like, okay, adding a rear wing, like our rear wing, we know like what kind of downforce it'll make, how that'll shift Aero-Balance. And then if we add a splitter, okay, what size splitter do we need to do? So it helps us like kind of ballpark what we need. And sometimes what we thought would work well, like if a part that's on the shelf, like say one of our wings, be like, oh man, that actually doesn't shift the Aero-Balance as much rearward when you do a splitter. So this car might not actually need that big of a splitter to be balanced compared to some other platform, which requires a splitter that's actually 3 inches longer to balance the car out. So that's kind of like, so we do go into CFD pretty quickly. But I would say the first thing is we visually look over the car.
And when you're looking at the car, I mean, do you look at it from a drag standpoint? Do you look at it from a standpoint of where the factory shape might have a lift issue, or do you go right to trying to improve the aerodynamics to make just downforce?
I guess a little bit of all of it. So we will look at like some unique things. A lot of it's hard to tell if it's going to be making downforce by just looking at it inherently. Drag is a little bit easier to see because like you can see a lot of things are missing, like maybe the underbodies. Like there's a big section of the underbody, which is notorious in American cars, less in German and Japanese cars. But
sure.
Looking at unique things, like what's really common today, you'll have like pass-throughs in the bumper that drive air around the tire. So small details like that we need to make sure that we capture also when we scan the car to then CFD to make sure we're capturing like unique details aerodynamically that you might not notice if you weren't looking over the car, because it would be really easy to scan the car and miss a little opening in the bumper that actually directs air around the front tire, and that could have a big effect on say dive plane design or splitter design or just getting your raw numbers more correct anyways.
Did you, when you were developing these kind of parts, did you always start from the point of using a computer to kind of give you that basis, like the base assessment? Or have you ever done anything that's a little bit, I don't know, like more arcane or let's say garage oriented to try and get a sense of what a car is doing?
So base wise, we have always started in the computer, but we don't go directly from that to production. We'll make a prototype and then we do test it as more of a baseline kind of thing. Like we'll do streamlines. We've done FlowViz, which I think is really cool. That like anybody in their garage could easily do like those specific things without a problem. Sometimes those can give you good information. Sometimes they can kind of give you not necessarily bad information, but not the full information. Like you'll like common ones, the strings, like put strings, see if like flow separate or anything like that. But that doesn't always tell you the full story because like on a rear wing. So if you're looking at data off a rear wing, as the wing angle kind of increases, you're going to increase downforce, increase drag. And then there's a point where the separation becomes too much where downforce drops off and then drag increases pretty heavily. Well, you can't really tell that's the point with like yarn. Because you can see it separating, but you don't know at what point that it is. So kind of what we use it for is we use it for checking what we're doing in the computer, because notoriously put bad information in, you get bad information out. So it like we try to do our best on the front end, but some things sometimes things get messed up or we miss something. So we want to be able to visualize it in the real world. And that's a lot of times why we actually do the flow viz, which is basically paraffin oil. And we use the actual chalk mix that you can get from like Menards that you basically mix in there and you spray on the car and then you drive around the track and it's basically, you see it in Formula One pictures, that green streaks, because we actually output images specifically for that. So we can actually look at separation on the car and look at it on the track and see if it's correlating well. So that's really what we use a lot of our, I would say, garage kind of stuff for. We do a lot of the tough stuff for louvers. I think that's great for louvers. So if you're working on like your car in your garage and you're looking at doing that kind of thing, there's a lot of good uses for it. But certain things like rear wings, I think it could give you not the full picture.
Okay.
But there are points where like, okay, so you're thinking about putting dive planes on your car, but you're worried about maybe the dive planes you're going to put on your car might hurt your rear wing. Like, because that's fairly common with some dive planes is you'll put dive planes on the car. You'll be like, oh yeah, that made a lot of more front downforce because I have more front grip. Well, that could be the case, or it could be hurting the rear wing and you're actually losing rear grip and it feels like you just have more front grip. So you could before you put them on there, you could put the yarn on the rear wing and then put the dive planes and then see if everything's still doing what it was before. And that'll give you an idea of the interaction. So there's things like that I think that a lot of like normal people could do to verify what they're doing is actually helping.
And how much, when you say you do the flow viz testing and stuff like that, I'm guessing you do that at a track so you can get to speed and such?
Yeah, so there's a track, Putnam Park, that's about, if there wasn't traffic, half hour from us west,
Oh, wow.
just directly on the same road. So, and we're members there, and I think it's like 200 and it's in the high 200s of days that we can go testing.
Wow.
So we basically have almost unlimited access to the track. So we go out there fairly regularly. We probably should post more on it. We're kind of bad at doing a lot of that kind of stuff on social, but we're at the track. Like Eric's been at the track two days this week already, and it's Thursday. So like,
wow.
It allows you to do testing where you normally wouldn't be able to. Like we have abilities that like obviously most garage, they don't have that much track access.
Right. That's fun.
But we were like, it made sense for us because we don't want to do that kind of testing on the street.
Sure. Well, and you need to be able to test in real world conditions. I mean, it sounds like even if you have an idea, even if you have a CFD model that tells you need this part here, you still need to build it, put it on the car, and then go out and drive it and verify that this does do what I think it was going to do. And just in driving the car, it does make a difference, or maybe it doesn't make as much of a difference as you thought.
Yeah, and that's a big one. And the really big one is when you're talking about feel is Aero-Balance, because that's one of the areas that like we still struggle with, especially making parts for street cars, because like everybody sets up their car different. Like one person, like if you change the ride height of your car, you do all kinds of things, that's going to change the Aero-Balance of the car. And different drivers like different Aero-Balance numbers, and that's like a learning process still for us today. Luckily, Eric does most of the driving, so he likes a little bit more front balance than we usually give when we set up a car. So when we release like a kit for the FRS BRZ, it'll usually be a little bit more rear bias than front bias, because the average driver likes a little bit more rear bias because it's more comfortable. So they feel that, so because it's more comfortable, they personally can push the car harder, even though maybe a little bit more front grip with a professional driver would get better lap times. So that's kind of like a area that we've been playing with, because one of the things at the track, there's a professional driver who used to race in Kart Series, which was now part of IndyCar when they split and came back. He's a professional driver out there and does coaching, and we basically pay him to do A/B testing.
Oh wow!
And he can give us feedback. So that's kind of a lot of what we've learned a lot from the Aero-Balance on that kind of stuff.
And what I was going to ask is, could you kind of maybe just define Aero-Balance? What you mean when you say Aero-Balance?
So it's just the amount of downforce on the front versus the rear. So like if you had a perfectly balanced car, 50% front, 50% rear. When we look at CFD numbers, I actually do it on all four corners. because we actually run the cases in slight yaw. So I actually run the airflow slightly sideways, because usually on track, you're never going to have perfectly, you're going straight, but there's always some wind. So you're going to have a slight yaw flow, and straight on can give you some falsely high values than what you would actually get. So that's kind of what it is. So I actually do it front left, front right, rear left, rear right. But in generality, most people are just thinking front and rear. No different than your weight balance. It's just, think of it as like weight balance, where your center of gravity is. Same concept. It's just your aero loads.
Okay. And so basically more front balance, more front aero balance means more front downforce, so maybe more front grip, and more rear aero balance, more rear downforce, more rear grip.
Yeah, and there's like things that you can play with. So like ideally you want your aero balance behind your actual center of gravity for stability reasons. It's safer. So when you actually make your aero balance forward of your center of gravity, car's more unstable. So it's like a fine line between that area of where you can play with.
Wow.
That's what you're supposed to do. So, but some drivers are different.
Sure.
Like we worked with Jackie Ding, and he wanted a lot more front grip than we've ever given somebody before. So
interesting.
He wanted, that was what he wanted. So that's kind of what we pushed for, based on like the factory numbers of what we were getting from his previous setup. And he had an amount that he wanted to increase that in the front. So that's kind of what we targeted, which would be more front than I would normally give.
And this was on his Supra, if I remember right.
Yeah.
Okay. Wow. So, and I guess, I mean, we should maybe talk about that. So you guys develop parts. You have like a lot of parts that are for street car that would be functional on the track. You have full on race parts, but then you guys also do like projects like that, where if somebody has a race car, they know they're having an aero issue where they want to develop the aero. That's something you could help people with as well.
Yeah, we don't do a whole bunch of it usually, just because, like, realistically, to improve the car to the level what most people want, it's not necessarily the expense side on us. It's not the scanning and the engineering and the CFD. Surprisingly, that's the most expensive. It's the manufacturing.
Oh yeah.
Unless you can in your garage make molds off like CAD, like that kind of thing, and lay the carbon or however you want to manufacture it, that is usually the biggest like hold up on developing something. It's always because of the front. Like, so usually for those types of applications, they usually run our rear wing. So we have two big rear wing parts. We call it the V1X and the V2X. So the V1X is like, so if you look on our products and what we sell for like race cars, we have stuff for Porsches, and they all run the V1X. And basically the V2X is that same main element, but it adds a second element. So it makes it a dual element. We do that on a lot of time attack builds. If people come to us, that's what we use. And then it's developing the front. And to balance out that type of rear wing requires a pretty complex splitter, which is expensive to manufacture. And that's usually the big holdup for most people to get it manufactured.
So if I'm reading between the lines there, a wing, I mean, everybody knows what a wing is. That's easy to picture. And you can just pick the wing, like you have two options, and then all that's involved is putting the wing on the back of the car.
Yeah.
So maybe in some ways fixing the rear downforce or adding rear downforce is the easy one, but it sounds like front downforce, that's maybe where it gets a little bit tricky.
So front downforce, I think, is actually easier to make, but it's more expensive to make. So it depends, like what will like. So for me, like the engineering side, me design something that makes a lot of front grip, it's really not too difficult, because you're close to the road. So because of being close to the ground, it's actually easier to make that downforce, because you have what's called ground effects.
Sure.
The rear wing, because it's already a mold, we're limited on the width because there's only so wide you can go. The cord length stays the same because that's part of the mold. So like the biggest dual element we have is 1950 millimeters long, and it's whatever our standard cords are. Main element's 300 millimeters, our second element's 200 millimeters. And it adjusts from, the top element adjusts from 30 to 55. So once you get to 55 degrees, that's all she's got. So there's no more rear downforce to create. Now you can kind of play with it. So there's kind of some cool things you can do depending on your rule set. Like So say you can make a lot more front downforce than the rear wing can make. Well, you can do, because Aero-Balance is just it's just a balance. It's not necessarily raw numbers. Think of it like a wrench. If you hold a wrench further out, it's a bigger leverage. So if you push the rear wing rearward, you can make more front downforce and still keep the car balanced. So those are things that you can kind of play with that. So that's why I think the front's kind of easier, and you can kind of dictate how much downforce the car's going to make based on the front, and you can adjust the rear wing to it. And usually with the rule set, we're actually limited on splitter size and things like that. So the splitter ends up being the limiting point. We actually have to bring the wing in to balance the car out, because we want to, basically when we set it up for the balance, we want to put the wing in a middle point, so you can adjust more downforce in the rear and less downforce in the rear, because most front splitters aren't adjustable.
Right.
So if you're going to adjust balance, you're doing it on the rear, which is different than most professional race cars. Usually you set the downforce level in the rear and you adjust in the front, but it's a little bit different because it's like a street car / GT car.
Sure.
Setups.
Interesting. Dussex, you've been awful quiet.
Well, it's funny, he said something that which I think is pretty awesome. I think Aero-Balance is counterintuitive sometimes. And so when you had mentioned you actually, to get more front effect, pushing the spoiler further back off the car, create more leverage, actually pushes the Aero-Balance forward. I think that's counterintuitive to what people think, but it's stuff that we've read before.
Well, so when you push the rear wing rearward, it will shift balance rearward, but so it allows you to actually make a bigger, more downforce in the front to balance that out. If I said it wrong. So when you move the rear, because you are making a leverage point further back. Does that make sense?
Totally.
If you have, say you have a wing that makes 500 pounds of downforce and it's straight over the rear axle, and then you move it 2 feet behind the rear axle, the 200 pounds of downforce is the same, but because it's further back from the rear axle, you have more leverage, and so it actually has more of a net effect, a greater net effect.
Well, so what it does is you have the same effect, but it's lifting up the front more. And because it's lifting up the front more, you need to make more front downforce to counteract it, which means instead of making 500 pounds in the front, you have to make more. So instead of say it's a magical thing with just a wing over the rear axle, a wing over the front axle, and they both make 500 pounds. You shift the one in the back rearward, still making 500 pounds. But now it's unbalanced because the wing in the front's still here. So you'd have to move it more forward, which then it'll balance it out. But if that was a splitter, you're actually making the splitter larger, which means the splitter's then going to make more downforce to balance it out. So that kind of makes sense. So you can net make more downforce, even though your rear downforce
is the same.
Number is the same, because it's all balancing based on leverage.
What this highlights,
it's moment equation. So if you're really nerdy and you want to look up the type of thing, it's called moment equations. It's like second year. Usually you just see them on wrench problems and things like that in engineering, but it's the same concept.
And what this underlines is aerodynamics is not easy, and it's not always obvious, and it's not always straightforward, and the thing that even just in that little conversation, I know that there's a lot of variables to consider, but it's like, I think there's even more variables to consider than that. Because if you're talking about the amount of rear downforce and how much it lifts the front, and then spring rates would come into it, suspension setup would be part of that. I mean, it probably gets pretty into the weeds pretty fast.
Well, and if you want it on the rear wing, so we're just looking at the downforce, but a rear wing also makes drag. And the rear wing sits up high, usually. So you're basically having something high with a force going this way also, and a force going this way. So technically, the actual force is going rearward and back, so it's not just the downforce pulling it down, the drag is also pulling it back. So the more draggy it gets, actually lifts up the front too.
Which makes it harder to balance.
Correct. So there's a lot of things that kind of go into it, which is usually when I'm talking to somebody who wants to just buy some parts for their car and put it on their garage and do some testing and go fast on the track, I tell them to keep it simple, because there's a lot of very simple things you can do that almost always work, and then you can get a good setup with. And don't make it too complicated. I think a lot of people, at least in our industry, because they like racing, they end up also liking the top levels of racing. So they like Formula One. They think the cars are cool, which they are. They're super cool. But then they try to look at what's going on in a Formula One car or like an LMP car and want to do that on their car, but they have no idea what's actually going on and why they're doing what they're doing. And they're trying to get too complex when keep it simple.
Sure.
Simple works.
I love simple. Let's
Yeah.
So like, I mean, I'm guessing it's basically to focus on the rear wing and the front splitter and just try and find some kind of balance and setting just between those two components that gets you close to where you want to be.
Yeah, because like you can buy rear wing. Tons of companies make good rear wing options. You can put on your car, take it out, drive it, see how much that kind of felt like it shifted. Make a wood splitter. When wood was cheaper, it would be a lot cheaper to do it.
Sure.
But like in essence, we'll say that's cheap.
Yep.
Put it on there. Okay. I would put the wing in the middle of its adjustment range. Take it out there, see how the car feels. Do you need more front? If you think you need more front, then you could lower the rear and see, okay, does it take a bunch of degrees out to actually do it? Well, if it takes a bunch, well, maybe I should actually make the splitter a little bit larger. So cut out another piece, a little bit bigger, and then put the wing back. Does it feel better? You could do things like that, or you can. Well, one thing we did is we actually just screwed splitters into splitters. So we just kind of like basically had an addition that stuck out, and we would take wood. That's what we did on one of the track days doing some testing is we just had some pieces and just shifted out a splitter just to kind of figure out where we like the balance on the specific car. Because we were getting weird values in the computer and like some things weren't really making sense based on feedback. So that's one of the things we did. So there's a lot of things you can do that's simple and that you can figure out very easily. And that's kind of how I would go about like that. And then there's things like kind of flat underbodies, like more basic diffusers that you can build. Follow like the simple things of like 7 to 12 degrees and things like that. Don't overthink it, because once you start getting too complex, you could just be messing up the whole situation because you don't really know what's going on. And even like I do this all the time, and like there's a reason why we run hundreds of iterations of designs, because I'll run something, I'll be like, oh yeah, this is gonna be awesome, and it's not.
Man.
So like,
Yep.
you so you have to do the testing. So keep it basic, and then go out and have fun.
And I think where people have a tendency to like really start to try and get elaborate with things is they want like once you get a feel of what downforce can do, it's like, okay, I want that, but I want more of that. And it's just like, okay, well, what else can I try? It's like the craving for more and more and more downforce. And so that's where you start throwing more and more things at the car. You get a little bit crazy sometimes.
Yeah. And I think that's where probably people would be better off. Like maybe, and you can make a good amount of downforce without doing it. Like there's a bunch of people who make dual elements that are like not super big, or like a good rear wing, like a single element, where then you could add like a splitter and then start adding diffusers to the splitter. Like there's companies that like Professional Awesome makes diffuser tunnels, like AJ Hartman. We make one, but we don't really like publicize it because we actually use it on the Porsche cars, but like we do sell them occasionally. But basically adding on diffusers to your splitter, start doing that. You can make a more downforce than I think the average person realizes by just focusing on keeping it simple, but a good setup.
Sure.
Focusing on setting it up correctly instead of trying to just throw parts at
it. Now I want to ask, so you talked about the flow viz tests and your rear wing end plates that you put out a while back. You did CFD and then the flow viz tests on those with basically the louvers in the end plates on the wing.
Yeah.
And that was amazing, by the way, like looking at your CFD and then seeing the flow viz directly underneath it and how you thought it was going to act, how the computer said it was going to act, and then basically how it acted. Which I thought was really cool, but the keeping it simple and then adding little things like that to the setup. You know, like you start off with some square end plates on your wing, but then you start adding little things like that where you're actually channeling more air under the wing, creating the vortices and things like that. Like it seems like there's a lot of F1 influence in that F1's been doing crazy things like that for a while.
Yeah.
I mean, is that where you came up with that?
So in essence, yes. So the goal with those end plates specifically was focusing on the wingtip vortices. Like that's the one big thing. If you look up wing information, like tip vortices, which is supposed to be as alleviated as possible with end plates. And the bigger the end plates, that's where you get bigger the end plates, the better, because you're eliminating as much of those vortices as possible. That's one of the reasons. Bigger down also allows more suction, things like that. But in essence, if we just focus on the vortice, and what I mean by that, it's basically a tornado. So if you have an end plate and you have airflow going this way, it's like the tornado coming off the end.
Yeah.
So what that does is that actually creates drag. So when that creates drag, that's going to make your wing more draggy than if you could reduce it. So what those vents do on the top specifically is it bleeds some high pressure off, and it actually goes the opposite direction as the vortice. So it actually decreases that vortice coming off the wing. But you have to also realize it does bleed off some of the high pressure on the top side, which isn't a huge deal because the high pressure side is not what's making the downforce. It's the low pressure side. So you lose a little bit of downforce, but you gain efficiency because you decrease more drag than the downforce lost. So if you wanted to go for maximum downforce, you wouldn't have those vents. You would close those vents because you are bleeding off some downforce, but that does come with more drag. So our focus on that wing was to make it kind of as high of as efficiency that we could make and still make it like a high downforce wing. And basically that alleviated more drag than downforce lost.
And that is a huge thing. I mean, like with my car, it's fairly underpowered car for what I'm trying to do. I've tried to do some big aero on it, but with it being fairly underpowered, trying to be as efficient as possible, trying to keep up with some of these, reduce the drag, 600 horsepower cars in the straights that I'm just getting eaten alive by. So that's a really neat thing as far as
that's a really interesting concept.
Downforce, but making it more slippery.
And on like a concept of like that, so usually a rule set will have a specific width the wing can be. So if you have a specific width the wing can be, and you're in a rule class, make your wing that full width, because the longer the wing is, the more efficient it gets. So you can actually then, and because it's longer, it'll make more downforce per given angle. So you can reduce the angle, so you're going to be making the same downforce with less drag. Hopefully that makes sense.
It just so when you say longer, you mean wider, so like width-wise? Okay.
Yes.
Okay.
The longer that is, the more efficient it'll get. So ideally, if your rule set says 1,800 millimeters, you should go 1,800 millimeters. And because then you could drop down the wing angle to say like a 1,600 millimeter would actually get you the downforce you need. Well, go 1,800, decrease that angle of attack, you're making less drag but the same amount of downforce, and then you just made your car more efficient.
Man, that concept alone, I mean, so many of us that have gone out to try and find something to make downforce, I don't know where drag has ever factored into it, but that what you just said makes so much sense. It's like you want to make downforce, but with the minimal amount of drag penalty. I mean, it's kind of what you talked about there, Scotty, but it's just, man, that seems like a pretty rare concept to consider if you're looking at wings or splitters and all that.
Yeah, and I don't think the average person in their garage necessarily could do a whole lot of that necessarily. They just hope the parts they buy, the people who designed them, did their due diligence on that aspect, just because it's really hard to quantify drag on your car without just doing like coast down testing. And honestly, like coast down testing can work, but it's so hard to do because of wind change. Like at least where we are, it's so flat and the wind changes like all the time. It's hard to get, we've tried to do coast down testing a few times and get correlate drag. And we've got it like one time to be where we feel like we got good numbers, but the other time the winds were changing and everything like that. It's so hard to do. So like, I always focus on people who are making good parts, and then your end as the end user should be focusing on making those parts work well as a system.
And so what I'm kind of to go back like to the simple approach of like a splitter and a wing, it seems like part like 1A of that or the second part of that is still focus on those two parts, but then think about something like wing end plates. Like, is there wing end plate, or can you change the wing end plate, like you're saying, to either maybe reduce the drag of the wing but still maintain downforce? Can you do anything to the front splitter to maybe make it more efficient, like you're saying with the diffusers to put onto it or something like that?
Yeah, the diffusers are by far the best way to increase the efficiency of a splitter. And when we're talking about efficiency, like, so efficiency is just L over D, so lift over drag. So how much, well, for race cars, it's really downforce over drag, but all the nomenclature comes from planes. So
yeah,
L over D. So like a good wing, like a really, really efficient wing would be like 12 to 1. So it's going to make 12 pounds of downforce for every 1 pound of drag. If anybody's saying it's getting more than that, either the wing doesn't really make any downforce, or they're just they're snake oil. Like, you might have like 13 or something, but if they're saying like 16, it's not realistic. So, but like a front splitter, you can make like an L over D of 30 with a good set of diffusers and depending on ride heights and things like that. So you make 30 pounds of downforce for every 1 pound of drag. So it's much, much more efficient when you start playing with those things, which is where you can really start to add efficiencies. I'm a big fan of find the most efficient rear wing per downforce level you want to go with, build a splitter and run diffusers, because that's going to be
the diffusers in the splitter.
Correct. Yeah.
Okay.
Sorry.
All right. Yeah. All right. I've got to ask about rear diffusers.
Okay.
So, because I think you guys have a couple of rear diffusers. Would it be fair to say that on a street car, for the most, like, especially trying to bolt something on, the degree to which that could be effective is not the same as the front?
Correct. 100%.
Okay.
The big thing with diffusers for like a lot of the streetcar applications is really you gain efficiency because it does decrease drag. Because a big issue with a lot of street cars is you do have that buildup of pressure behind the car. You have the weight coming off the back of the car. The diffuser helps clean that up. We've never tested and found a diffuser that didn't at least increase mile per gallon a little bit.
Really?
That we make. So we like a lot of our focus, because you're limited on what you can do based on price and based on like the exhaust and location and making it fit around multiples exhaust. We mainly focus those on drag.
Okay.
Unless we're doing race car parts. Race car parts are a little different, but on a street car, that's really what we focus on.
Sure. One question that I've always had about a rear diffuser is how essential is a flat floor to making a rear diffuser actually like more functional?
It depends what you're looking at achieving. At the end of the day, you're always going to achieve more with a flat floor than with that. If your goal is to reduce drag, you don't really actually need a flat floor, if that's your goal. Because really what it's doing is it's got to be a decent diffuser, not a bad diffuser. But if you're with a good diffuser and with no floor, what it's going to do is it's going to basically come onto the diffuser and it's going to go up the diffuser and bleed into the back of the car more efficiently than just air going underneath the car. However, how diffusers work is it's not actually the diffuser itself that makes downforce usually. Like, it does make a little bit of downforce, but very small. It's what's in front of it that actually then makes the downforce, because you're speeding up the air in front because you're then filling a void behind. And because it wants to fill that void, it pulls more air under. So this area in front of the diffuser is what's really making downforce. So if your goal with a diffuser is to make a ton of downforce, then yes, you need a flat floor. But if your goal is to reduce drag, you don't need a flat floor. If you just want to make a little bit of downforce and reduce drag, you don't need a flat floor.
Well, and like we talked about earlier, like reducing drag is still going faster, and there's benefits to it.
Correct. And if you can make a little bit of downforce with it, then it's a win-win. That's how we view the rear, like a more basic street rear diffuser.
Okay. All right, Scotty, I see the wheels turning. Now, part of the reason I asked about that, Scotty has built a rear diffuser. So, and just because Paul, and for anybody else at home that is not familiar, so Scotty has a 2011 STI that is his race car, and he's racing in TT3, so he's limited 10-to-1 power to weight. So he's making under 300 horsepower because the car weighs right about 3,000 pounds. But so that's the balance, and front splitter, rear wing, and he's put a rear diffuser on it to try and get some more downforce going and that sort of thing.
Okay.
Yeah, and cleaning up that wake was like a thought. Just adding a little bit of extra downforce was that other thing. Like, I mean, again, I have no CFD. I sit here and I drink beer and I stare at my car and go, maybe that'll work.
Yeah.
So I mean, we try it out, and I know the car handles well. Whether or not it's right or not, I couldn't tell you, but it works for me.
Mm-hmm.
But yeah, I mean, it's a neat idea of just like the not necessarily downforce, but cleaning up that wake behind the car.
Drag reduction.
Yeah.
Yeah. And there's other things you can do. I don't know if sometimes they're legal or not, but there's definitely ways around because rule sets are kind of just meant to be like, okay, you read it and then find ways around it type of
Sure.
thing. Like you could do things like through ducts. I know a lot of people hate it on the car, but it was a few years ago, the Nissan, like the GTR LMP car, that was the front wheel drive and then the electric in the rear, and they never got the electric to work. That car was really, really fast in a straight line because of how they designed like through ducts to the car. So there wasn't a whole lot of weight in the rear. So there's things you can do, like you could run like a NACA duct or something in the rear side windows, because I'm assuming the Subaru is a 4-door.
Yep.
And then basically duct, almost like NACA ducts on NASCAR where they use it for cooling, but you can run ducts to the back trunk and just cut a hole. So you're feeding air from the side that's decent air, but you're feeding it in and then out in that wake region and decreasing that wake region. So there's a lot of things you can kind of do like that. That's really not probably against the rules that you could do to implement drag reduction, especially on something like that where you're limited on power.
Sure.
That definitely helps a lot.
And me and Ryan have been talking about cutting holes in the trunk for a couple of years now. Neither one of us has got around to doing it.
Hey, I cut the wrong hole once.
Put it in the floor, I believe.
Yeah.
Yes.
And at like 100 miles an hour, it was raining up to the front windshield inside the car. But, that was more of the circumstance thing.
Yeah. Well, so Paul, maybe I want to approach it from the other direction, especially doing testing, like as much testing as you've done. What are some of the indicators that you might have in the driver's seat as you're doing testing that the balance is way off, that things have gone wrong? Something is not working to the point where you should probably be aware of it and try and go and like undo what you just did or take off what you just put on, something like that.
So a lot of that would be, you probably need to drive the car without any of that first. So you have to know how the car naturally feels. That's a big one, because it should feel, until you start getting to high downforce levels, you should have an overall same feel as the car. So if you're normally not pushing real hard into a corner, you had a rear wing and now you seem to be plowing a little bit more, maybe pull a little rear wing out of it. Like basically it's all, at the end of the day, a lot of that's just feel of the driver, and it's hard to really know, but you have to know how you like the car to drive. Like some people never want the back end to get loose. So you're going to have a different kind of feel than what somebody else might like. They want to get a little loose because they want the front to have as much grip as possible on corner entry. So a lot of it is, what did the car feel like when you, I guess, stock, and when you set it up for how you like it. And then once you have, like without aero. So once you have your setup of how you like it without aero, start adding aero and then make sure it still feels similar. Like it's going to feel a little bit different because you're going to have aero, but like that similar feel of turn in, or exit, everything like that.
Or maybe if it gets worse, like if you know what the car handles like and feels like, and you put on a rear wing and all of a sudden it's like, well, now my steering is more vague. It's worse. I don't have as much turn in, like something has gone the opposite direction of what you were hoping to make a change in.
And I'm a big proponent in, like, when you're making changes, do one thing at a time. Because if you do multiple things at a time, it's really hard to figure out what's actually causing the problem.
Sure.
So even if I know I was going to put a rear wing and a splitter on the car, given we can go to the track whenever we want, so it's easy for us to say this, but like put the rear wing on, go out and test, see how that car now feels different. Now then put the splitter on, go out and test. And then you can start to really feel how these big changes affect it. And you like, especially when you talk about like a splitter, you can have the splitter and you can already have the diffuser tunnels maybe already on there, and then just make some plates, some aluminum plates that actually cover up the diffuser. So you go out there on a track day, you have the diffusers covered, drive it for a few laps, then take those off, drive it. Then you can start to really feel how different changes actually feel on the car. And then that's gonna, the more driving time you're gonna have with your car, that you're gonna know when something doesn't feel right then.
Gotcha.
Without that time in the seat, it's really hard to know.
Sure.
Yeah, that butt
I guess the first thing that we do, going back to like what we do when we first get a car, is we also take it to the track after it's scanned, so we know what the car feels like stock.
Sure.
We made the mistake before, like, oh, cool, we got the car scanned, we drove it, like just drove on the street, and we made some changes, but we didn't actually know what it felt like factory. And we're like, is this actually worse or is it better?
Right.
Like, it runs good times, but is it actually better than what it should be? Like, so you have to have that seat time.
I guess maybe the last question I have is when and where does suspension start to come in? Because I know like if you're doing time attack and you've got a decent size rear wing and you've got a front splitter, probably even a lot of the off-the-shelf spring rates from a suspension standpoint might not be sufficient if you really have a functional rear wing and a functional splitter. Can you talk a little bit about where you guys look at it making a suspension change, or where you would really start to want to do that?
So I'm definitely not an expert in suspension. So take this with a kind of, so what we do is when we do things, we end up then calling up the suspension manufacturer and being like, hey, these are the changes we made to the car. What do you guys recommend for spring rates? And that's a good starting point. And that's what we use as a starting point, because I don't consider myself a suspension expert. Like, so like for some of these things, like we'll call up like KW, be like, hey, this is the platform. Like, they already make a setup for this car. This is the platform. These are the changes we've made. This is the downforce that we estimate it's making. They recommend a spring rate setup. That's what we'll run. And then we can kind of tweak from there. And by we, somebody else than me, because that's not really. So I hate to like pass the buck on that, but that is definitely not necessarily my expertise. Like, I know a little bit, like if I was messing with my own car, I know what I would do, but I hate to give out information that isn't necessarily 100% correct. So that's what I default to, is that, and then kind of tweak from there. Obviously, like if you're adding more downforce, you need to have more spring rate. That's obvious.
But I mean, have you noticed anything like a correlation of like, we're making 500 extra pounds of downforce front and rear, maybe add, a 2 kg higher spring rate? Or, I mean, is there any sort of correlation between the amount of downforce to
how
rates that we're recommending?
I view making sure you have enough downforce, or I mean, not enough downforce, enough spring rate, is how the car is acting dynamically on the track. So if you're running the car, I want to make sure that how I set up that car fairly statically, if you're running down the straight, you're keeping around that same rake. So like, say you're 25 millimeters lower in the front, going down the straight, I still want it to be about 25 millimeters lower in the front than the rear. I don't want the rear to be softer so the front's starting to lift up. But then when you start talking about the dynamics of corner work with suspension, that's where you start playing with, okay, how much downforce do I make? Am I going to, then it's just like, okay, so you're going to have to focus somewhat on aero and then somewhat on suspension. So you're going to have like an okay setup on suspension, okay setup on aero to make the whole system work well. Or do you focus 100% on aero at the detriment to suspension? Like, you could, like, there's a bunch of different kind of thought process you can do with it. I would say on most people, you should kind of go the medium route, medium downforce, like medium setup on suspension, set up the suspension so it works with aero, but not too much to the detriment of your mechanical grip.
And it sounds like, if I'm hearing that right, one of the indicators is if you're making enough downforce to really start to squish the car on the front or the rear or both, that may be one of those indicators that you need to look at spring rates.
Yeah.
Like especially like if you've got a big enough rear wing that you're going down the back straight, and like maybe take some pictures or whatever, have somebody take pictures, and the car starts to squat down aggressively.
Mm.
That, maybe that's because you don't have a splitter. Maybe it's because the springs just can't stand up to it. But if you really feel like that movement, that it's time to
and
look
that's
into.
one thing we're working with now. Like one of the reasons Derek was going to the track is we were testing a front splitter, and it was fluttering a little bit. And it was fluttering because the car was making enough downforce that it was, as you were driving, it was going down and then touching the ground. And obviously when it touches the ground, you basically lose downforce. So when you lose downforce, it lifts up, then it starts making a ton downforce, it goes back down, and that's what causes the fluttering or porpoising or whatever you want to technically call it. So that car does need more spring rate or need to raise the car up. Like those are other solutions. So it's not just necessarily spring rate. You can do other things mechanically to the car to get it to work better if you don't want, like, so that's something that you would do on say an aero car on a medium ground if you still want to be able to make that downforce, but you don't want to go too stiff because it hurts your mechanical grip. Well, raise the car up. So it's not
you got more room.
Straight. Yeah. So Putnam's kind of a slow track. I forget how fast the car was going, like 120-ish in the straight. So it's not like a super fast track by any means. So it would also be track dependent in what your local track is, or if you travel all around the country, go to different tracks, you might set up, especially if you're playing that middle ground, you're definitely going to set up you might want to tweak how you set your car up on each track.
Okay. Sure. All right, Dussix, you look deep in thought over there.
I was actually sitting here thinking about how am I ever going to go 180 miles an hour at COTA?
More power.
Yeah.
Yeah. That's kind of, so thinking about my aero package for my time at that car, my aero package is going to be a lot smaller than Scotty's, but a big part of it is because you're talking about traveling to different tracks, the tracks like Road America, tracks like COTA. I mean, there's so much time in these straight stretches, and these corners aren't that tight that really trying to keep that aero balance light while when you're limited to a horsepower number is like one of the things I've been thinking about a lot lately.
Yeah, and that makes total sense. You look at like going back to like a higher level of motorsports like Formula One, they have different setups for every single track.
Yeah.
And that's because that stuff matters when you're limited, and they're limited on power too, no different than anyone else basically by fuel rate, but or I think at least it used to be.
Yeah, fuel rate.
So you have a different setup for every track because every track's a little bit different. So if that's kind of like, if you're stuck on a horsepower number, you might tweak your setup to be faster on some tracks than the other.
Yeah. Modular. I mean, we've talked about it. Scotty and I have talked about it, having a modular setup where you can add stuff, take stuff away, dual elements, single elements, bigger, smaller. Even I never ever thought about blocking off the diffuser tunnels in the splitter, but man, that's pretty genius idea. Actually, I like that.
Yeah, and there's actually two ways you can do it, at least with the professional awesome ones, because they have the flange on the backside too, so it has the flange all the way around. You can actually bolt something to the backside of it, which seems kind of counterintuitive because you're like, oh, well, that's just going to create a bunch of drag. It's actually not that bad. Or you can do the ones on the bottom, but the ones on the back are easy to do without lifting the car. Porsche does that on their GT cars. Like they'll have a little block off on the diffuser that you can remove or take off based on the rear wing angle. So like if you go to the higher angle, you can pull those off or you can leave it on, and that's their balance on it. And it's just a little plate on the diffuser on the front splitter.
So you're just talking about like the diffuser comes up and you just put basically a fence on the back and leave the bottom alone, and that,
because that would be really easy to change, like just in the paddock, just setting it up. If you set it up correctly, like maybe some bolts going through and then like a wing nut, you could have that on in no time.
Could you use that as an adjustment as well? Maybe like 50%, like block off half of the diffuser?
You definitely can. I don't know if it would say cut 50% of that downforce or what that number necessarily would be, but yeah, you could fine tune it. There's actually aren't even very tall. Theirs is probably only an inch tall total on their like the Porsche ones. So, and the diffuser, the end of the diffuser is actually taller than that. So I don't know what they necessarily did. We never tested different heights. We've just tested it with it and without it, and that's what it's doing. And that's what their media from their publication type of things also says what it's used for. So you can also do that, and that would be easier for the average person to do without getting underneath the car.
Okay. What about fences? Like adding fences really adds downforce. Is it a nominal change? Bigger fences, smaller fences?
Are you talking about in the diffuser or like something on the bumper that kind of covers the front wheel on the splitter?
Not spats, like on the actual splitter itself. So like
like a 90 degree
plane,
or something.
Yeah, versus like a 90 degree on the edge of the splitter itself.
So what would go 90 degrees? Like if this was the end plate going this way, a piece like this. Yeah, those help. I like to think of them as a gurney, even though they're not really a gurney. But what they do help is they basically they function very similar to a gurney. They're just a lot taller. You're basically building up like stagnation on the top side of the splitter, like higher pressure, but that's not really what's making the downforce. It's the spillover and increasing the air going underneath. That's what that helps. So yeah, that does help, and that's a very good way to adjust because you can make a bunch of different sizes of those and change them really quickly. Mm-hmm. So that's a good way to do adjustable, making more like fine tuning the front. I guess you're not going to have like big, like when you cover up a diffuser on the splitter, that's a big adjustment. But adjusting those would be a fine adjustment. So you can kind of, in doing that, you would have to really know your car.
Sure. Could you think of that like as far as if you have different heights of those rear fences for the front splitter, could you think of that kind of like adjusting a wing angle per, like think about it like a little bit more, a little bit less, and to find like it's a fine tuning versus like a big change?
Yeah, 100%. You just do have to be careful not to go too tall, because then you're just adding drag and you're not once you get to a certain height, ballpark, I usually probably wouldn't go over 50 millimeters to 2 inches tall. Okay. Usually that's a very like overall number, but I would say like 50 millimeters, depending on your setup. But like if it's sticking out fairly far, so if your bumper's ending right here and your splitter's coming out and this is where your end plate, say you're connecting this far material, I wouldn't really go much more than 50, because once you start getting higher than that, yeah, you start to make a little bit of downforce, but you're gaining a lot more drag because that is open completely in the air. It is right in the front, right around the bumper. You're getting the highest speed coming around the bumper because your bumper's right there, and you have your radiator in the front, which slows down air right there, and then all this air is wanting to go around the car. It's going the fastest as it goes around the bumper, and then it's hitting this big wall. Is very draggy if you have it tall.
Man, like we said, it gets complicated fast, but
you can usually, like, if you keep it to a certain height and then adjust from there, like you don't really have too much to worry about. So like, don't go too high, don't go too crazy. You're usually fine, and then you can fine tune with that. End plates is another thing you can play with like that. End plates are a lot less of an issue of going too big, because it's not really in yaw situations it is, but then it's kind of helpful because it helps with air going underneath the splitter and things like that. So really too big on end plates, I don't really feel is a big deal. It's more of a looks thing at a certain point. Like you want to go a little bit below the splitter, probably above, depending on what material you make, above whatever your grind material is on your splitter, so you don't tear them up, but
right,
a little bit lower, and then kind of as big as you really want them to be, where they're not flopping around.
Sure.
Because you're not going to really hurt. But once you start going smaller and smaller, you can start losing a little bit, and you can start kind of tuning that way too. So those can also be devices.
Another thing that I'm kind of taking away from this is one of the things maybe to think of when you're thinking of aero is that more is not always better. And very quickly more can be worse. So it's kind of like that less is more. Like you want just enough aero to get the effect that you want, but not much more than that, because then you start paying the drag penalties and that sort of thing.
Yeah, unless you're building a full out like aero race car. Like if you're building a full out aero race car and you're going for like that type of thing, and you can make power. This is a big thing. If you can make power, like say you're making 800, or like if you're on the unlimited class,
yeah,
it doesn't matter. I would say go downforce, downforce, downforce. Ignore drag as much, really. It's not as much of a problem.
As long as you can make enough power to push through the drag, it doesn't matter because your benefits from the downforce is going to be there.
Yep. Because if you think about it, like, so drag where drag is noticeable when it slows you down is obviously in the straight. Everybody notices that because your number is smaller. Instead of 127, you're doing 125 or something like that, and you're like, oh man, I lost 2 miles an hour. But you're never looking at the speed mid corner when you're cornering at 5 miles an hour faster, and you spend way more time in that corner or the multiple corners that you're gaining that speed than the straight. Given when you're limited on power, that's totally different, because if you're having so much drag and downforce that you can't actually really push the car through a corner, like if you're not on the limit if you can't make the car on the limit in the corner, you're probably not making enough power where that's the type of situation. But if you're in the limit class and make a ton of power, downforce.
Yeah. Well, what is more interesting to you to work with from like a design standpoint? Something where you have almost an unlimited amount of downforce you could potentially throw at a car, or something where it's a lot of just small tweaks and fine tuning, where you just want to get an improvement, but with kind of like the minimal amount of change?
It probably depends on the week. I could go back and forth between them. If I did like 3 projects where I was focused on like drag and fine tuning, I'd be pretty excited for like a big downforce setup. But if I've done a bunch of downforce setups, then it's like I like to go back and forth, and like it just keeps my mind like moving in different directions and keep it like trying to learn new things. Because like a lot of our goals is every time we do something is the next one to improve it. We should be doing better every single time.
Well, and almost back to the beginning where you're saying like the holes in the bumpers where you've got this flow that's coming around the front wheels and stuff like that. Have there been instances where you're looking at a car, you scan the car in and you look at something and you realize like there's something like, why did they do that? That doesn't make any sense. And you can make like a little change or little adjustment to either reduce drag or maybe take out some lift that the OEs just kind of for some reason put into an element.
Yeah, so there was like on the Ford GT350, they have like, and I think it might be because it's the difference between like a GT350 and the regular Mustang. It's that S550 chassis. They had this opening in the fender where it was just like open, and I think it might be because they actually run a different under part in the front because it's running a different engine. It's just open, and like the fender liner just stops, and then you have like all of this stuff right here, right where the tire is, and right on the inside. And I'm like, this is really, really messy. I'm like, why? Because usually when you have a fender liner, it runs all the way down, and it's like, because fender liners are good, so everybody should run fender liners if you can. Overall, so because I see people take out fender liners, and I don't really know why. The fender liners to keep smoother airflow and help air get out of the wheel wells, but they just left it
open.
Yeah, and there's other things that we saw people do, and we like learned like why they're doing it. Like the Porsche where I was telling the block off on the diffuser. When we first saw that, we didn't know what that was for. We were like, this is really weird. Why'd they put this here? And then we tested it, and we're like, oh, that's why. They also have some turning vanes on the underneath where it's not behind the front tire. It's kind of inboard. It's just like 3 straight pieces, but they're just turned a little bit slightly coming out. Yeah. And it's like, okay, they're handling the tire work. Which, that's kind of what it was doing, but it actually really, if you remove those, the rear diffuser makes way less downforce on that car. So you add that, we actually applied that to another car, because we always knew that stuff like that would help kind of decrease the tire weight from the front, because that's what I always thought their main purpose was. But maybe that wasn't their main purpose. Maybe the main purpose is to get better airflow to the diffuser. But that's what we found out on that car. So there's a lot of things like that we see and then we test and we're like, okay, what is it doing? Usually we try to, because we're very curious, we try to figure out what things are doing. Even if it's not something that we can make parts for or sell anything for. Like we don't do anything with those on that specific application, but it was cool to know what they did.
For sure. Well, it's
Yeah,
like
you
we
got-
got these OEs that are playing with wind tunnels and like they're able to like do all that little stuff. It's pretty cool to reverse engineer that.
Yeah, the engineers at Porsche are not dumb. So
No.
there's tons of little things on there where my buddy's got a 992 turbo, and I spent more time laying on the ground just looking underneath that car at the crazy little things that they were doing. To pick those guys' brain, like, oh, this is just a road car, and you're doing all this cool little stuff. Some of it's for downforce, some of it's to reduce drag. But yeah, that's interesting.
Yeah.
All that
Cooling,
stuff.
right?
Yeah, they do a lot of that's by far out of the cars that we worked on, the most interesting that we see underneath from the factory of what they're doing aerodynamically, because they do a lot of really cool and interesting stuff. Their rear wings actually make downforce. Their splitters actually work. Like some of the other cars, it's fairly surprising. Like you see it and it's like you test it, it's like, wow, this isn't really doing. Like it looks like they spent all this money on like trying to make it look very aero, and like the wing doesn't do much. It's just like it's like a goofy 3D wing, so you normally think it wouldn't do that much, but they spent all this time and effort on it. Why wouldn't you just make something that works like Porsche? Like their stuff works,
Right?
Wow.
and it looks good. So why not?
So you've seen factory wings that like seem like they should be functional, but they're not really doing a whole lot.
They do stuff, but not much.
Yeah.
It's
not
like,
for the effort that went into it.
yeah, not for the effort that went into it. Like a primary example is the new Corvette. Like one of the options is their wing, and it's like the factory wing. It's terrible.
Is that just the little one that sits just above the? Okay.
No, there's an optional one that's like an actual wing too.
Okay.
But it's tiny. It really doesn't do much.
Okay.
I'm like, why did they? And they could have made something like the GT3s or the GT3 RSs with an actual like wing that makes real downforce. Because even like the GT3s have not as cool, I would say, cool of a wing as the GT3 RSs. Like the GT3 RS is more like a wing you would see on like a time attack car. And that makes the most downforce, but the GT3 ones make really good downforce. It's integrated into the trunk, just like a lot of other like factory wings are, but theirs makes downforce.
Wild. All right. Well, Paul, first, thank you again for making the time to sit down and talk with us. We've been going for a while, so we're kind of winding down. And I just want to thank you again for scheduling the time and chatting with us about all this stuff. Really appreciate it. As we are winding down, Scotty, Dustix, did you guys have any other questions that you want to throw out there?
No, I just want to say thank you. It was a
for
good
sure.
talk.
No problem. Thanks for having me.
Well, and the coolest thing to take out of this, I think, is just how much. I mean, I knew you guys did testing. I knew you guys like you have the reputation of like putting up, CFD and like trying to really show that you're trying to make a part that is functional. But I didn't realize how much real world testing you're doing on top of all of that. That's pretty phenomenal.
Yeah, we don't. It was one of the things we've always been working on is trying to improve that image also, because we're not marketing people, we're engineers, and it's like we go out to the track and it's like, oh yeah, we went out to the track and maybe show some pictures of some cars like in the garage, like, oh, these are like, that's usually what like we post, but it's like we are actually there for a reason. Sometimes we can't share the reason, but like
sure,
we're working on our own stuff, like we can share that kind of stuff, but we don't a lot of times. We probably should, but yeah, we do a lot of actual testing at the track also.
Well, we will not keep it secret. We will let people know. We'll try and put it out there.
Cool.
Well, very cool. Well, thank you again, Paul, for all the information, for all the insights and sitting down with us. Really appreciate it. I guess we will end it there. And until next time, just say thank you to everybody for watching and for listening. And until next time, stay tuned with Flatirons Tuning.
Thanks everyone for tuning in to the Flatirons Syndicate Motorsports Podcast. Once again, we'd like to let you know that your support is what makes this show possible. Be sure to check out our online store at flatirons.com for any of your aftermarket or OEM Subaru parts needs. And as always, stay tuned with Flatirons Tuning.